Hello guys, welcome back to Smart Interviews YouTube channel. I am 𝗙𝗲𝗃𝗲. Today, let's see Codeforces Division 4 problems. Let's get started. So let's solve problem from Codeforces Round 1017 Division 4. Let's start with the first problem. So in this problem, this says that 𝗟𝗶 is in a strange world where each country has only 3 strings. Okay, the first string of the first letter of each string is concatenated to form the country's modern name. So you're given the country's ancient name, they want you to give you the modern name. So it looks pretty simple. If you come here, you can clearly see, right? If you have United States, they are just taking the characters, initial characters, U, S, and A, and they are writing so. And if you see the remaining test cases, we are going to follow the same. Followed by the constraints are also not that harsh, and at max the length of each character is going to length. So yeah, I think the simplest approach will be just taking the input and concatenating the first character, for example United States America, and then for second OMG, then ICL, and then followed by the same. So let's look the code. So let's start the code. So here I have some by default code, and yeah, in the other tab I have my editor. I have my problem statement, and in this tab I have my custom test section. So they are given t number of test cases. So let's take the number of test cases as the input. So for each test case, I need to take the string as the output, and note that we need to take the complete string. So str se dot next line, and I will directly split it up. So since I am splitting this up, I can just take the array, and in the output I can just print it like str of word 0 dot character 0. That means the first character, followed by the similar thing for character string 1 character 0, string 2 character 0. And yeah, there is a high chance that the code won't work. The reason is, since you are taking 𝗟𝗏 line, the enter will also be taken as the input. So to avoid this, we will just write 𝗟𝗏 line before the while. So let's run the example. I will just copy the input from here. Let's test it. USA, OMG, ICL, and followed by we also have the correct test case. So let's copy the code and submit it. Okay, we can see that we have got the option of accepted. Let's move to the new problem. Okay, so let's start with the second problem. So you can pause and read the problem statement. I will just quickly go through. In this, you're given like there is an infinite number of houses. There are an infinite number of houses on an infinite number line, with the houses at infinity to -1, -2, 0, 1, 2, and till the plus infinity. On day 0, he has started a plague by giving an infection to unfortunately of resident 0. each succeeding day, the plague spreads exactly one healthy household. That means this, okay, infected household. It means that it from 0 it can spread to exactly one household. That means it can be either to 1 or -1. It can be shown that on each day the infected houses form a continuous segment. Okay, so it won't be random, like it will be like continuous part, either -1 to 2 or minus. It won't be like -2 0 1. It will be continuous. Let the segment L house and ending at the rth house be denoted as LR. You know that after n days the segment LR becomes infected. Okay, you need to find out any such segment L dash R dash such that it could have been infected on the mth day. Okay, in the input you're given each test case as NL NM LR. So, and you need to output two integers L dash and R dash on each on new line if there are multiple solutions. Output any. So if we just consider the test case 1, okay, first of all let's get to the idea. If I am given a number of houses, 0, infinite number of houses, they are a number line. Let's say on the nth day, the infection is from -3 to 4, and let's say there is the some nth day. In the when they want mth day, the infection will definitely be in the range from L to R. That means L dash and R dash will somewhere be in the range from L and R itself. So there will be definitely one confirmed thing, right? Let's say in the day 0, if it was if the infection was only from 0 to 0, on day 1 it can spread to either 0 to its first neighbor. That means day 0 it was like this, day 1 it can be 0 1 or -1 0. So either this can be the option or -1 0. On day 2, if you're having infection from 0 to 1 on day 1, you can have infection either from 0 1 2 or -1 0 1. So here you can have two possibilities from here, -1 to 1 or 0 to 2. But if the infection was in this way, you can -1 to 0. It can have again the same similar thing. So if you are having an infection like this, on the day 2 it can go from -2 to 0 or it can go to -1 to 1. So the other possibility is -2 to 0, and in this way it continues. So this is a problem statement. By saying this, I can confirm one thing: L dash and R dash, the whatever the range be, it should be completely from in the range from L to R. Second point is your 0 should definitely be included in this range, L dash to R dash, and yeah, obviously it will also be in the range from L to R. So by keeping these two things in the mind, and one more thing we can identify, right? We can tell that L minus R. Okay, your R dash minus L dash will be equal to M, and your R minus L will be equal to N. So this is the third thing that we can tell. And the difference between whatever thing we need to remove is, I can get it like D equal to, I am calling it as D equal to N minus N. This D is nothing but, let's say, before we come to D, I can tell that okay, I can copy the same thing. If I have infection on, let's say, day 5 from -2, this is my N equal to 5 from -2 to 3. So day 0, day 1, day 2, day 3, day 4 and day 5. So in this way, on day 5, your L and R are nothing but -2 to 3 on, and you are given a value M. M is always less than or equal to N. So it can be like, let's say 3. So there can be many possible answers here. You need to just find out it. So can I do in this way, whatever the difference is, 5 minus 3, which is 2. So I can keep the possibility like, I will simply remove this part and this can be my new L dash. And yeah, this can be the possible answer. Why? Because day 1, day 0, day 1, day 2 and day 3. So this can be the possible answer. And this can be my new R dash. But what if, can I always chop the portion from left side? I can either chop the portion from left side, I can also chop it from right side, right? If I do the same thing, will it work? So 5 minus 3 is 2. So if I chop it from here, this can also be my valid answer, L dash and R dash. I can simply remove 2 portions from here. So day 1, day 0, day 1, day 2 and day 3. But what if, so let's say there are 2 ways, right? Either I can chop from left or from right. I will choose chopping from left. So I will just see the chopping from left option. So if I chop from left and if I say I've changed my M to 2, so the difference comes out to be 5 minus 2 is 3. So if I chop 3 from left, I will get like 1. But, is it possible? Is it satisfying the second condition? No, right? This is satisfied anyhow. But is it satisfying this? No, right? Why? Because 0 will always be there in our infected house. So you need to handle this. So either what I can do is, whatever I can chop till 0, I can chop it. My L will not be greater than 0. This can be my last L dash value. Whatever the remaining is there, I will chop it from right. I will chop it from right in this way. So this can be my new L dash and R dash. This I can get it if I say this is L. This can be my whatever my L was there minus your N minus N. So I can call this as like difference. I can keep this difference and I can separate it. So yeah, there are two conditions ideally. If my L is greater than or equal to n minus m, I can directly chop it from left. Or else if I have the condition like this, L less than n minus m, what I will do is I will chop extra part from R. Chop additional thing from R, which is nothing but our right side, which I can do it in this way. So let's see the code. I hope you have understood this explanation. Let's see the code. Okay, so let's quickly see the code. In code, as you can see, we have 4 inputs. So I can take it like int n, followed by, I can repeat the same thing for m, l and r. Okay, so the L and R are the range according to n, but we need to find out for m, and we have assumed it, right, a difference n minus m. If this difference is less than or equal to L, okay, not L, absolute of L. Why? Because L is by default negative value, so difference is highly going to be less than 0. So absolute of L. If so, I will chop difference from the L. In that case, my output can be will be chopped from left by difference signs with a space. My R will be the same. But if the other case, if the difference is greater than absolute, then my left part will for sure become 0. My left range will for sure become 0. But we also need to chop it from right. If my right, I will chop it like my L plus whatever the difference I have removed from left. Whatever the remaining is there, I will chop it from right. So let's see if it works for, and yeah, it need not match with the current output, as the output format says if there are multiple solutions, output any. So according to our logic, I can expect the output to be like, for 4 it was minus 2 to 2. For this, the expected output can be 0 to 2. According to our logic, the output can be 0 to 2. For the second test case, 4 1 to 0, 4 0 to 4, in that case, if I am having 1, my output is expected to be, my output should be like 0 to, I can say 0 to 1. And in this case, the output will be same. Why? Because n and m are same. In this case, last case, the output, expected output is to be 5 minus 5 comma 3. Let's see, are we getting the same output or not? Yeah, as you can see, 0 to 2, 0 to 1, followed by minus 1 to 2 and minus 5 3. So we got the expected output. So I hope you have understood the code and logic. Let's move toward the third problem. Okay, so let's start with the third problem. The third problem says that a person is trying to learn some secret passcode, which is a permutation of 2n elements. To help, a person gave him a n cross n grid, okay, in which g of ij contains p of I plus j. So basically this line says that g of I j contains the permutation of I plus j. Okay. Um, then given the grid, please help 𝗏𝗃 crack the forgotten code. It is guaranteed that the permutation exists. Okay. It can be shown that permutation can be determined uniquely. Okay. So they're saying you need to crack this sequence P sequence with the help of the given grid, and they tell that every sequence is present in this grid. And as I mentioned permutation of 2n elements pair, they have mentioned a permutation of m integers a sequence of which contains 1 to m elements. Okay, when they tell 2n, they mention like if the n is equal to 2, the sequence will have 4 elements, any 4 elements, a1, a2, a3 and a4. And these elements, they will be in the range from 1 to 4. They can be in any order. So for example, 1, 3, 2 is a sequence, but 2, 1 is also a sequence, but 1 to 4 is not a sequence. Same with 1, 3, 2, 3. In each test case, you are given n followed by the grid. And it is guaranteed. Okay. Then, yeah, you can see that in the example 1, this is my first grid in the example. If I carefully observe this, if I draw a table and represent it, 0, 1, 2, 0, 1, 2. For understanding purpose, I am considering a table of 1, 2, 3, starting with the 1 based indexing. So when we have 1, 6, 2, it means like this is nothing but my G grid. My G of 0, 0 is 1, which is equal to P of 1 plus 1, P of G of 1 comma 1 is 1, which is nothing but my 1 plus 1. It is the second number in my sequence. If you observe, we have 1 as a second output, P of 2. Then then we have 6. G of 1, 2 is nothing but my 6, which is equal to P of 1 plus 2, which is 3, which is my third sequence, followed by G of 1, 3, which is 2, which is P of 1 plus 3, which is equal to 4. So my fourth number in the sequence is 2. If you follow this, then we have 4 and 3. So this is nothing but my 2 plus 3 fifth sequence number, followed by 3 plus 3, which is my sixth sequence number. But if you see, now we have one more, if you see, we have 6 here, followed by, it's a symmetric, our G input matrix is a symmetric matrix. So if I iterate only on this, the first row followed by the last column, I can get the sequence. Or else, since we will be taking the input, while taking the input itself, what we can do is, when we take input from 0 to n, for j 0 to n, but yeah, since we're considering 1, I will go from 1 to 1. So 1 to n means I'm including both the values. I can simply do it like my P of I plus j equal to the input, or else anyhow I will be storing in the input, right, ij, read it, I can do it like P of I plus j equal to G of I plus j. Or I can eliminate this G completely if you don't require. So in the sequence, you can get 1, 6, 2, 4, 3 from this matrix, but we don't have 5. 5 we can get with the observation that we'll have 1 to 2 elements. That means we have 1 to 6 elements except 5. Since we know the sequence 1, 2, 3 going till some 2n, we can expect the sum to be 2n plus 1 by 2, sum of first n natural numbers formula. And if we subtract whatever the sum which we get from the matrix, we can get the first value of the series. Okay, so our step 1 is to get the series from the second index till the 2nth index. Then second part, this you can get it from the matrix, from the G matrix. But for the P of 1, I am considering there is a 1 based indexing. For P of 1, I can get it like 2n plus 1 by 2 subtract the sum of 2 to 2n. So these two steps will help us to write the code. I hope you have understood the problem statement followed by the explanation. So it's quite a direct problem. Let's see the code for it. Okay, let's quickly see the code. So yeah, we need to take the matrix first n followed by the matrix as the input. So I'll be taking the n first 1 base indexing, hence the size will be +1. And I would also require a p array of size 2n plus 1. So let's quickly take the matrix as the input. G of ij followed by I can fill the p array with this logic, p of I plus j equal to g of ij. This will help us to fill the p array from 2 to 2n index, but we also need we are only missing the first index in p. I can get it like sum get me the sum, okay, from second index till the 2nth index in the p array. Once I get it, I can solve it like I can get my p first value like 2n into 2n plus 1 by 2. 2 into n plus 1 by 2. Subtract it the sum with sum that we get, and yeah, simply print the array. For okay, not from 0, from 1 till the last index. So p of I, since I want the lines input to be the same line, it should be print followed by to avoid any wrong answer, ln after the for loop. So yeah, I think pretty much it should give us the expected output. 5 1 6 2 3 2 1 1 2 3 4. Yeah. So yeah, let's go to the fourth problem. Let's start with the fourth problem. You're given two drums, left and right. So a hit on the left can be recorded as L and a hit on the right as R. A strange forces that rules this world are fickle. Sometimes a blow sounds once, sometimes it sounds twice. Therefore, a hit on the left drum could be as either L or LL. A hit on the right drum could have sounded as either R or RR. Okay. So basically till now you're given two drums, one is L and other is R. So if you hit once, it can get L or LL. If you hit on the right drum once, it can be R or RR. So there are two possibilities. The sequence of hits can be made on the string. The sequence of hits made is recorded on P. So original sounds which are beaten are P. The sounds heard on the string are in the sounds heard are in the string S. So the actual hits of the string are there in P, but the sound recorded is there in S. Given P and S, determine whether it is true that sequence S could have been the result of the hits from the string P. So you need to simply check, is P, can it be P or not, by with the help of these two conditions. So for example, LR, if they are P, then the result could be LR or LRR, LLR or double L double R, but it could not be triple LR or LRL. Okay. So basically you need to check, you're given two strings S and P. You need to check, is L can S be P? Considering these two conditions, it can be L, LL or R or RR. So in the input you're given two strings. You need to just input yes or no. If I take the example of, maybe I can take this as an example. So L 5 L's RL followed by 4 L's double R double L. Let's see, they are saying no for this, and let's take the other. Let's also take this one as the example. Double L R L R L double R L triple L R L double R double L triple R L. So if you check, maybe these two L's can be the output of this one L, and these one L can be the output of this L. Okay, this is S and this is P. So this R can be the output of this R, and this L can be this L. This two R's can be, okay, one second. Let's just read the problem statement once. Okay. The first line of each test case contains string P. My bad. This was string P and this is string S. So from this L, we could have sounded these two L's. From this L, we could have sounded this single L. This R can correspond to this L to this, followed by this R could have produced two R's, then L to two L's, then this R could have sounded 2 times, this R could have sounded once, and this L can correspond to this one. So yes, for this there is a possibility that this S can be P. But if I come here, this is my P, this is my S. Okay, this 2 could have corresponded, these 2, and yeah, this L could have corresponded these 2, this one to this. But here in the original hit we have only we have one extra L, but in the sound where it is heard, we can see we have only 4 L's. So can I say that this is not possible? Why? Because in S we could have extra L, but we can't have number of L's less one compared to P. Assume it like let me just remove all these things. So the input was LL RL. Okay. Now here assume like this. Assume in P this is a one component, followed by this one is a second, third, fourth, fifth, sixth, and seventh. So did you see in P I have made components till I get the other character. So I will keep a pointer, and if both are same I will increment. If both are same I will increment. If I get a different character now compared to previous, I will just start a new character count. And similarly in S, these 3 can be termed as one component. These are another, third, fourth, fifth, and sixth, and at last seventh. So I have created components whenever I get the next one is a different character. If I have all the same characters in the string, this entire thing is one component. If you see, in P we have 7 components, in S also we have 7 components. If at any time I see the number of components are different, I can simply return false. So in, for example, like if I am having P and S, LLR and RLL, in this also have 2 components, but these 2 are completely different. Why? Because this L doesn't correspond to this, and this R doesn't correspond to this R. So hence, I no need to keep track of L or R. I can simply keep track if the initial characters are matching or not. If the initial characters doesn't match, I can return false. Okay. So one thing is, the first character like S of 0 should match to P of 0, followed by the number of components. So number of S components should match to number of P components. And if you observe, if I have 1 L, I can produce 2. If I have 2 L's, I can have at max 4 L's, but this is the maximum. At minimum, I should have at least 2 L's. So the count in P should not be less than the count. Okay, the count in S, this is the count in S, should be either equal to the count in P, or at max should be double the count of P. So what I mean is, for any character count, let's say in one of the component, if I have a count of, if I have a count like, let's say, for this, I have created one integer array would be sufficient. Two integer array would be sufficient. Let's say vector for P, vector for S. So if you are having a array like initially 2, then 1, then again 1, 1, 1, 2, 1. Then for VS, I can have it like 3, 1, 1, 2, 2, 3, 1. So if you see, we have 7 components in both of them. At any point, if my VP of I, it should be either, it should be in the range of, okay, VP of S should be in the range of VP of I to double the size of VP of I. It should not exceed this range. If it is exceeding this range, I can simply return false. Okay, so this 3 will be my logic. So I hope you have understood the code. You might be thinking that why are we only storing the strings? As I have already mentioned, if the first if the first character is not matching, if you are having RR L, then LRR, then these two doesn't match, right? So we can simply return false from here. If you are having LLR, then yeah, if this is for S, this is for P, we can produce 2Ls, right? So yeah, it can be possible. Hence, yeah, again it becomes false here. Why? Because 2Rs should be either 2R, but it should not be less than the count of VP. Hence, only checking the first character will help us, followed by every time check what is the component size of VS. It should be in the range of this. Okay, so let's quickly see the code. Okay, so let's quickly see the code. Scanner. So I'll be using number of test cases. So I need to read two strings which are continuous. Let's say we have P string followed by S. So P se dot next followed by string S. So I'll be using a function this time, system.out.println. Let's call a solve function. We'll pass P and S to it. So static, a string return type, and the function name is solve. I'll be passing string P and then followed by string S. If, yeah, according to our logic, if my s.𝗟𝗃0 doesn't match with s.p.𝗟𝗃0, then I can simply return no. Else I can move forward with logic. According to our logic, I need two separate array lists, right, for S and P. So array list of type integer for VS, or let's say VP first, new array list, the similar type of array list, we would require for VS. And yeah, I'll be using a additional thing like s dot. I'll be adding dot in front of S and P. The reason is I'll be comparing it with the previous values. Like when I'm iterating on P, like P dot size, P dot length. So if my P dot caret I, if it is equal to P dot caret I minus 1, then I will simply do count plus plus. But yeah, since I'm using count variable, I would also require count. This count is to add the count of a component. At point when they become different, I will add this to VP dot length. Okay, VP dot add count and reinitialize count to 1. And after that, at any point, like if my count is not becoming to 0, then I can simply add the remaining count value to VP. And then yeah, I can initialize my count to 0 to reuse it for the string length S. So I'll be iterating on. I can iterate from 1. Why? Because I'm comparing with previous value, right? 1 S dot length S and VS. Once it is done, I will simply compare. At any point, if I have more number of components, v dot size, if it is not equal to VP dot size, simply return no. If it is passing, I will compare each component length. So if I'm iterating on, let's say VP dot 0, since both the sizes are same, I can iterate on any one. If my VP dot size, if it is at any point greater than VS dot size, then that means VS can't be the, okay, not size actually, VP dot get I. Comparing with the component size. If this is true, or if my VP dot value, if my VS dot value, if it is greater than twice the size of VP, then in any of the case I can return false. If no, I will continue. At the end, if it is passing all the above cases, I can return true. True means yes. Let's run it and let's copy the test cases from here. Array list. Okay, we need to do the necessary imports, right? Import dot util dot star. Okay, yeah, as you can see, we have got the expected output, and yeah, this is the following code. That's it for this video. So if you like the content, make sure to like, share and subscribe. If you want to learn coding in detail, you can join 𝗏𝗏𝗃𝗏𝗏 Smart Coder course for 3 months. And yeah, that's it. We'll meet next time.